Hello and welcome to our fourth and final video on trigonometry and the area of triangles. Let's scroll down to our question number 4, our challenge question. And what I've added on to our triangle, the black triangle that was originally given, is a right angled triangle. What you have to do is, if you're not given a right angled triangle and you need to use trigonometry to find some missing things, then you've got to actually add somewhere a right angle triangle. So you could sometimes add a triangle into the middle, so a couple of right angled triangles in the middle, like we did in the previous exercise, or you could add an extension perhaps to the triangle and create a right angled triangle. Okay, so in this particular case, with this type of long and extended triangle, it's good to add an extra little piece appended to the side here of it. Okay, so now we've got a red triangle, and it's a right angled triangle. Straight here and then straight up and then straight across, that is a right angle there, 90 degrees. Now, we could find this side here, CD. The reason why we want to find it is that is in fact the height of the black triangle. If AB is the base, then CD here is the height of a black triangle. Now we are given BC. BC is 85 millimeters, and that's our long side. And when you're given the long side and you're trying to find another one of these sides, such as the opposite or the adjacent, you start with a number. We don't use divide at all, we just go 85, and because it's the opposite we're trying to find, it's sine. So 85 sine 61, put it in the calculator and you get 74.3. Well, let's just quickly do that. 85 sine 61 equals 74.3 millimeters. Now we can just use that straight away. We can say, well, we know AB, which is our base of the smaller, the black triangle. That's what we're trying to find the area of, not this whole thing. No, we just put this extra little bit on here to find the height. Okay, and that height is going to serve as our height of the little black triangle. All right. It's also the height of the red triangle, but that's not relevant. It's the height of the black triangle as well, so we're going to use it to find the area of the black triangle. So we go base, which is AB, which was 45 millimeters, times that height CD that we just found out, 74.3, divided by 2 will give us 1671.8 millimeters to one decimal place. Alright, let's move on to our super challenge. So there's lots of different ways of solving this, and you may have solved it yourself. I don't really expect many people to actually be able to solve it. It's extremely advanced, really beyond year 10, but some of you would be up to a challenge, perhaps just a few of you, if you're interested in it. What we do here is, there's lots of different ways, as I said, of doing this, but break it up into two right angled triangles, and then we can use trigonometry. Okay, we're given 51.1 meters, and that's actually a long side of this small right angled triangle here. We can find the slightly shorter side. You see that it's slightly shorter than the side over here, 51.1. Okay, and it's also opposite the 85.6 degrees. Okay, so when you're given the long side, and you're trying to find the opposite, we go 51.1 sine 85.6, which is the angle, equals 50.9. Just always check, please check, does it make sense? And yes, it does. We started with a long side, 51.1, and we ended up with a slightly shorter side, 50.9. Always check, just check to see if that makes sense. We got 2 meters. Well, it's way too small. Doesn't look like that. It looks like a little bit less, doesn't it? Alright, And if we got 53 meters, well, that's not our long side. We've got to have something slightly shorter. And we know immediately that we've made a mistake if we don't get something slightly shorter. 50.9 meters. Alright, we're going to eventually use that as our height of our triangle. Think of this triangle being flipped over on its side, so that PR becomes the base and QT ends up becoming the height. Alright, now what else do we need? We need to find the base along here, which is PT and TR. We can find TR, that bit, and then we can find PT later on. Okay, so TR is just going to be the same as what we did before, but we're using cos because we're trying to find the adjacent, which is next to the 85.6 degrees which are given. So we put into our calculator, let's just do that, 51.1 cos 85.6 equals 3.9 meters. Alright, now in order to find this side PT, we need an angle. We're not given an angle yet. Now that little bit in there, that blue area, that's a small area there. We're given the whole of this blue area. The whole of it is 45.5, but we need to find just the blue area that's inside this top right angled triangle, which is a lot less. It's not half, mind you. You can't just divide the 44.5 divided by 2. You end up with two right angled triangles that are different this time. Remember over here we were able to halve it. That's a special case because we had a triangle which was isosceles. We could halve it. This is not isosceles. Alright? You can't halve the triangle, halve the angle in here. It's not as simple as that. Alright, so instead we're not even going to use that angle at all. Not at the moment anyway. What we're going to do is find this angle over here, and then we can use that angle. Now within any triangle, isosceles, scalene, right angle triangle, any kind of triangle whatsoever, the angles inside are going to add to 180 degrees. So we can find this angle here, QPR, by subtracting the other angles that were given from 180. So all of us in here is inside this whole angle here. Big angle is inside the big triangle. Alright, and we've got the other angle is 85.6. Subtract both of those from 180 and we end up with 49.9 as our angle at the very top here. Alright, now we can use that now to introduce tan. It's a little bit easier using tan. Now tan is used when you're dealing with the adjacent and the opposite. Alright, so far we've been dealing with things that contain the long side, which is for sine and cos. But for tan, it's different. We're only dealing with the adjacent and opposite. Okay? Tan is the adjacent and opposite. No long side at all. Alright? Now, if we start with the side that is opposite, we move along, we know what the opposite is. We've got what was it, QT, we worked it out to be 50.9. okay, and if you're trying to find the adjacent, which is next to our angle, we figured out 49.9, alright, then you use divided by tan, in fact. So we've got 50.9, which is our QT, we're given that, that's our opposite, and we're going to go 50.9 divided by tan 49.9 equals, and it's 42.9 meters. Alright, So notice that this one here is shorter than that one, so you can know immediately, well, is it meant to be a shorter one? Okay, so yep, it's meant to be a shorter one here. We're trying to find PT, so we're likely to be correct here in finding that 42.9 is indeed shorter than the QT, which was 50.9. Alright, so we've used tan to find that there, PT. And we also know TR, and that worked out to be 3.9 earlier on. Now if we add those together, the TR and the PT, okay, we end up with that one plus this one here, 46.8 meters. And that's going to serve as our base of a triangle. Okay, now all we need to do now is the base, work out the area of this big triangle here, not any of the small ones, but the big one. We've got our base PR, and that was 46.8. Multiply that by our height QT, 50.9, divide by 2, and you get the area. Alright, so you could have actually, I've done it to 2dp. I haven't really stuck to my method of going to 1dp. Might be better actually, but that doesn't matter really. So we'll just have a look at that. 46.8 times 50.9 divided by 2 equals, I'll put it there. Okay, well that's probably why I wrote it down, because it's exactly that. But you could actually do it to 1dp and just cut off the 6. 6 is 5 or more, so that means that second decimal place is 5 or more. You can make the first decimal place, just make it up 1. So 1191.1 would be okay as well as to 1dp of accuracy. Alright, and there are lots of different ways of doing this, mind you. If you get an answer that is just near that, very close to that, then it's likely to be correct as well. I mean, it depends on, there'll be different rounding depending on how you've done this. You could have broken this triangle up in a different way. Maybe you broke it up with a right angle, 2 right angle triangles, cut this through here, and you could have put a right angle here and another right angle here. So there's different ways of doing it, and the rounding will be slightly different too, so you probably ended up with a slightly different answer. But that doesn't matter. If it's almost the same, then it's correct. Alright, so good luck on that. Thank you.